this question?
Well, I started, I haven't done the part on showing the coordinates of 4 points. What I wanted to identify was um, what 3 pi over 4 was in radians and then what my y coordinate would be. And then and then to figure out for the points that have the same y coordinate. Um, but I got a little stuck because I found 135 being the equivalent in degrees of 3 pi over 4, and that's the third multiple of 45.
Yeah, that's
Um,
right. So so let me check your work. You started off, so this is our sine function, right? That's what we're looking at on the graph.
yeah,
And they give us 1 point, which is given to us. And then we have to find out, determine the coordinates of 4 other points on the graph with the same y coordinate. Okay, so they want us to do the same y coordinate, but we have to figure out the other points. Explain how you determine the coordinate. So you said y is equal to 45. How'd you get this part?
how did I get 25? Okay, so what I did was I did a special triangle on the side, and I have my 45-degree angles here. So what I did sine of theta, which is 45, or close to theta, which is 45, I get 1 over root 2. But then I have to rationalize that denominator, and that means squaring the bottom and multiplying the top by root 2, which gives me that root 2 over 2, which is the equivalent of cos theta or sine theta, and theta in both cases is 45 degrees.
Okay, so that's 45. But what is this degree then, right here at this point? What's the angle here? Because we know that 0 degrees, and this is pi over 2, that is equivalent to 90 degrees, right?
Yes.
And what's pi?
Pi is 180.
180. And what do you think would be this middle one right there?
Uh, that'd be 135.
35 degrees, right?
And 0.
Good. Very good. So now they're asking us to find the other coordinates that have the same y value. Okay?
Right.
So once we eyeball them, so let's say that another one is going to be here, right? And another
Where,
one,
sorry? Oh, yeah.
or you will see the one I'm drawing in purple. Maybe I should do a different color.
Yes.
So right here.
Right.
So you agree that this could a possibility that's going to be there, or he's like, I don't know, I don't know if it's there or not.
No, that seems to be the possibility. Can you repeat?
Okay, so then we have to figure out the x value for it, right?
Right.
So what could be the x value for this one?
Well, seeing as the difference, at least with what you got in purple, um, between 90 and 135 was 45 to 45. If you do 135 minus 90, you get 45. And if you do 135 plus 45, you get 180. So I'm thinking that over here would be 2 pi. Over here, this point that you've marked in orange would be 2 pi plus 45 degrees. And the 2 pi is 360. Plus 45 is 405.
And then you said plus 45, that's 405.
Yes.
Okay, and how much would that be in radians? So because our coordinates are given to us in radians, how do we do that? What is pi? Well, one thing you can say is, okay, well, what's 45 degrees in radians?
45 degrees in radians is pi over 4.
Right, so then what we can do is to convert it into radians, we know it's 2 pi, right? Plus pi over 4.
Mm-hmm.
Then we have to do common denominator, right? Okay. What would it be?
It would be 9 pi over 4.
Okay, 9 pi over 4. So then we can say the second coordinate that we have, according to our labeling, would be at 9 pi over 4 and square root of 2 over 2, because that's not changing. Good so far?
Right.
So you do have to explain your reasoning behind it. And then we can see. I don't know, do you know anything about the period of a function?
Yes.
Okay.
If I'm correct, when we talk about the period of a function, we're talking about that horizontal length of one cycle on the graph.
Yep. So let's say I have this point here, right? I know that this point is going to repeat again at this point, right? It's going to repeat again.
Right.
So that's 2 pi. So then if I know every 2 pi units my points are repeating, I can find out when that point is going to come back again on my graph. So I know this point right here is at, first I need to know the location of my point. I know this is at 135 degrees, or it's 3 pi over 4, right? Now, this point is going to repeat again somewhere after here, but our graph does not continue there. So we can't find, well, I mean, we can find it, but the question is not going to, we don't need to find it for this part, because we're just looking at where our graph is on here. But we can still do the same thing, because this point here again is going to repeat here at negative 2 pi units, going up, and then it's going to go down. So we can say that the distance between here to the next point, let's say, because this is going to be the next point, right, is going to be 2 pi units. So how do we find something that is 2 pi units away from that location?
So you see the point that you just put in, orange is 2 pi units away.
Yeah. I mean, there's more than one way of doing it, by the way. We can try doing the same technique as you did right here. We can go back down here and say, okay, well, this is 45, this is 90, this is going to be 100 and negative 35, this is again negative 180. Well, what is this point then?
Oh, so 3 pi over 2. 270 and 180. That seems to be 225. Or, sorry. In radians, 225 is the equivalent of 5 pi over 4.
Okay, 5 pi over 4, right? So we say this is, well, because it's on the negative side, we'll say negative 5 pi over 4.
Yeah.
And then square root of 2 over 2. Let's see if this works out with the period. So we know that the period was every 2 pi units, right? So our starting point is here, which is at 3 pi over 4. And because we're going left, we're going to subtract the period 2 pi. So that's 3 pi over 4 minus 8 pi over 4. That turns out to be negative 5 pi over 4. So we just use the idea of the period to come to our answer. So again, more than one way of doing it. Or you can go individually count to see where it's located and how many degrees it has moved.
Right.
Okay. So.
And.
So that would be, we can say this is our point number 3. And it says we have to find out 4 other points, right? What's another one that you think you would like to do?
My only confusion, okay, so I thought that these 2 points were the same.
This one? And this one?
Yes, the ones I've highlighted with the black dashes, I thought those could be at 2 other points that we could do.
Yeah, we could. We could do actually 5 points on the graph. We ended up doing this one, right? This is exactly the same as this point and this point. All three of them are the same.
Yes.
Okay, so we can pick either one. I mean, since we already know this one, we can apply the understanding of the period, and then we can find out what this one is. Because it's 2 pi units to the left of it, right? So we said that this was 9 pi over 4. Number 2 was 9 pi over 4, right?
Mm-hmm.
So let's call this one the 4th point. So the 4th point then, if you're looking at the x value, it's going to be 9 pi over 4 minus the period, because this point is going to repeat again. So that's 2 pi. And then if you do the common denominator, that's 9 minus 8, which is equal to pi over 4. And then that just means that our point is going to be pi over 4, comma, square root of 2 over 2.
Right. But I know it said 4 other points. So we found like 3 pi over 4 and root 2 over 2 already.
Yes, you're right. So that means my mistake. That means we have to find this one right here. Okay. So let me go ahead, then find we'll call that one the 5th one, the 5th point. How do you propose we find this 5th point?
Pardon, could you repeat yourself for a second? You just cut out.
I said that, how do you think we can go ahead and find that one, the number 5?
Well, to find number 5, we could use the rule of the period. So we would just take 2 pi.
Well, where are we starting off with? Are we starting from number 4 and then taking the period away?
Well, we're over, we're over here. 3 pi over 4 and then moving out.
But hold on.
Moving left.
Do you think 5 and 3 pi over 4 are the same points?
Pardon?
Are 3, so this point, let me just, hold on. So you're saying that this point right there, this one, is the same as this point?
No. Sorry, I should have like the one beside it to the left. The one that we found is number 4.
Okay, so then you're fine.
And so because they're the same and they would therefore repeat, whatever number 4 is that we found, which is pi over 4, you would subtract 2 pi.
Okay, good, for the x value. And what would I get?
So pi over 4 minus 2 pi is that's made it 335, and in radians, minus 335, or I get it straight here. So then that would just be negative 7 pi over 4.
Very good. So we found the last point's x value. Good.
Okay. And so would you consider the 4 points that we just found to be theta coordinates? Because they're unknown?
Those are just our coordinates. Theta we already, well, yeah, that would be theta as well, because for example, pi over 4 is equal to 45 degrees, right? So we also find the theta along with their corresponding y value.
Right, okay.
Okay.
That makes a lot of sense now. Thank you so much.
You're welcome. Well, thank you for stopping by, and have a good evening.